Welcome to Taxonomy Online Mathematics. We are still on the tutorial on logarithm. We are done with the properties and the laws and the concept of logarithm. Today we want to see how we can use those principles or properties to solve a given question. So question number 1, we are having logarithm of what? 16 base a multiplying log 27 base a divided by log 9 base a times log 64 base a. We have to simplify. Alright, so in this we are going to check how best we can decrease these numbers. We can see that 16 and 64 have something in common. 9, 27 also have a common factor. But each of them can be broken into a base and an exponent. So inside this, I have log 4 exponent 2 give me 16. So base a, that will multiply log 3 exponent 3 base a, that also give me 27. I will divide that by log 3 exponent 2 base a, give you your 9. Then log 4 exponent 3 base a will also give you the 64. So in this case, what do? We apply the third law, which says that exponent become a number to multiply the logarithm. So I'll be having 2 log 4 base a times 3 log 3 base a divided by, in this case, I will still have my 2 log 3 base a multiplying 3 log 4 base a. So now that we apply the third law, I can see these two logarithms are multiplying. They are not the same as the product rule, whereby we are going to say let's use the 3, the 4 to multiply these 3. No, this is a logarithm on its own multiplying another log. So they are together. The same thing, these two are together. So we can easily cancel out common terms. We can say that 4 log 4 base a log 4 base a log 3 base a log 3 base a. So we can easily cancel the logarithm out, leaving the coefficient or the number multiplying the log. So in this case, I'll be having this cancelling this and this cancelling this, give you only 2 times 3 over 2 times what? 3. This 2 will multiply this 3 as a coefficient, 2, 3 as coefficient. So 6 over 6 will give us 1. So in simplification of this logarithm, the answer we are looking for is just what? 1 after simplification. I believe you get the concept. Good. Then the second one, this is subtraction. So we can employ the second law, which is what? Quotient rule. So I can say that this will be log x exponent 3 divided by x per the numerator here. This is subtraction. So we take our, how do you call it? The number, the argument. We divide the argument. That will be divided by log x to the power 2 over what? X. We can cancel, knowing very well that this log x to the power 3, meaning x times x times x 3 times, divided by x, one of the x will cancel. Or I will use the law of indices. Since I have the same base, there is a power of 1 here. I will subtract that from this. So I'll be having log x squared, meaning 3 minus 1 will give you x squared. Similarly, this will also give me log x. As in this case, don't forget, this is going to be a power of 1. Subtract from this, give you 1. So that will also give me that. Then I can still employ the third law, the power rule, which will mean that 2 will multiply log x divided by log x. And you can agree that since this is log x divided by log x, they can cancel out to give us our answer to be equals to what? 2. So in simplifying number 2, we still have 2 as our answer per the rules of what? The logarithm. We employ those rules. Now, you can also decide not to use the second rule. Directly, you want to use the third rule. Meaning, you are going to have 3 multiplying log x minus log x divided by, in this case, 2 multiplying log x minus what? Log x. So you can see this log x minus log x log x. So I can say that let the log x be, let's say y. What will I be having? 3y minus y. Algebraic expression. 3y minus y will give you what? 2y. Meaning in this case, you'll be having 2 log x, since log x is y. 2y minus y will give you only what? Y. And the y in this case is our log what? X. And still, the log x will cancel log x. Your answer will still be equals to what? 2. I believe you get it. Alright, let's take the third one. So number 3. Don't forget, log 27 base 3, 64 base 4, 47 base 7. The bases are different. So now we can try to break down the numbers, the argument, to see if we can get the base in it as a base of having an exponent. So in this case, I know 3 exponent 3 give me 27. 4 exponent 3 give me 64. 7 exponent 2 give me 49. So I represent them by that. Log 3 exponent 3 base 3. Log 4 exponent 3 base 4. Log 7 exponent 2 base 7. We are done with that expansion. What do? We apply the power rule, whereby the exponent will now multiply the log. So that gives me 3 log 3 base 3. This will also be log 4 base 4 minus log 7 base 7. Now we can see that this is the argument and the base are the same. Argument and the base. Argument and the base. We have an identity rule. So the identity says that if the argument and the base are the same, the log is just what? 1. Meaning the whole of this become 1. 1 times 3. 3. The whole of this 1 times 3. The whole of this 1 times 2. So in all, you have 4. Meaning this is going to be 6 minus 2 will give you 4. So the answer for simplification of this is just what? 4 per using the properties or the rule. Alright. Then the last one. The fourth one. This is log 8 base half. Log 32 base 1/4. We can say that the bases are not the same. So even if we break this to 2 exponent 3, 2 exponent 5, we may not be able to get the same base to cancel or the same log to cancel. So now we are going to employ the change of base property, which says that if I have log b base a and I need to change the base from a to c, that become log b base c divided by log a base what? C. Meaning this is the base. I want them to have a common base. So if they are going to have a common base, then the argument is going to be the argument of the numerator. Your base is going to be argument of what? The denominator. So checking this carefully, this is going to be, I want to change to base 10. If you write a log without the base, means you are in base 10. So I want to change this to become log 8 base 10 divided by log half base 10. Don't forget what we are seeing is just the numerator, the changing of base of the numerator. I want the numerator and the denominator to have the same word, base. So what do? I will divide. So I'll use divided by, this will be log 32 base 10 log 1 over 4 base 10. Alright. So in that case, I will now simplify this. This is not a base but a fraction, 1 over 2, which can be turned into an exponent of negative what? 1. This will be log 2 exponent 3 give me my 8. Log 2 exponent what? Minus 1 give you half. Then divided by log 2 exponent 5. Then this will also be, since I'm having base 2 here, this could be 1 over 2 exponent 2. So if I turn it to become a negative power, that will be 2 exponent what? 2. Don't forget 2 exponent 2 will give you 1 over 4, as in this case. Now I'm having the same base. So I can easily cancel because the base is 10, 10, 10, 10. I can cancel. But I need to employ the third rule, the power rule, to have 3 log 2 minus 1, which will be the same as minus log, divided by 5 log 2, then minus 2 log what? 2. So in this case, log 2 base 2, base 10. Log 2 base 10, we can cancel. Log 2 base 10, log 2 base 10, they will cancel. So I'll be left with 3 divided by minus 1 times 5 divided by what? Minus 2. When I say times, it should be division. This is division. So this, the log are gone. I'm left with 3 over minus 1 divided by, the logs are gone, 5 divided by what? Minus 2. So per fraction rule, 3 minus 1 times 2 minus over what? 5. If you change this to multiplication, you flip the fraction. So in this case, minus 2 times 3 will give me minus 6 over minus 1 times 5 minus 5. If you multiply through by a negative, or even a negative can cancel, so I'll be left with 6 over 5 as the answer if you are to simplify this using the change of base property. I believe you got the concept clear. Good. If you like this video, as you find it educative, don't forget to subscribe if you have not. Don't forget to like the video and comment, share, and God will bless you. See you in the next episode.